going to talk a little bit about composition of functions. And before I really get into composition of functions, I want to review a little bit about functions in general. Remember, a function is an input and an output, and you get to choose what the input is. It could be anything. And if we're looking at this function here in red, the f function, you're going to put anything you want into x. This rule is going to tell you what the output is. So for instance, if we wanted to know f of -1, then we simply just put in -1 wherever we see an x. Okay, and these are real basic ones, but you could have several places in the rule that have an x value. Now we're just going to simplify it. 4 times -1 is -4 minus 3, which is -7. So when our x value is -1, the rule takes it and spits out -7. You could plot this on a graph at -1, -7. Okay, but f of -1 equals -7. The x value produces this y value. Now that works for any value we want x to be. And in fact, we don't have to just have numeric values for x. We can have anything we want. And just for fun, I could evaluate this f function for a star. Maybe that star has some meaning. Well, we're just going to put it in for the x, because the x is just a placeholder for the information that we're looking for. That's basically what a variable stands for, is just, what do you want it to be in this case. So, we're going to use a star. Now, of course, you can't really simplify that down very far. It would just be 4 star minus 3. So let's take this idea and take it a step further. Let's say we want this information in our f function. It can be anything. It doesn't have to be a number. It doesn't have to be a star. It doesn't have to be anything. In fact, we can plug in a whole function into our original function. And that's what composition of functions is about. Now, before I do an example, I want to go over how they're written. A lot of books use this. Okay? And I don't like this. It doesn't really tell you exactly what's going on. But this is read f of g of x. Okay, they have this little open circle. It's not an O, it's just an open circle. This is equivalent to what I like to use as f of g of x. Okay, and I like it this way because it, just like in this function, whatever goes into this set of parentheses is what you're putting in for x. Okay, so now what's in this set of parentheses is a whole new function. So we're actually going to put this whole function g inside of our f function. Okay, so I'm going to use this, but you're going to see this a lot in different books. So let's go ahead and evaluate what f of g of x is. Okay, we know that our f function is 4x minus 3. And again, what that means is whatever value you want for x, the rule says multiply it by 4 and then subtract 3. So we're just going to set it up, and I'm going to kind of break it down. Right? X is just a placeholder. Right? Whatever we put in here, whatever goes inside the f parentheses, we got to multiply it by 4 and then subtract 3. Well, what do we want to put in the parentheses? Well, we want to put the g function in. But again, whatever it is, we're going to multiply it by 4 and then subtract 3. So what is the g function? Well, the g function is just -x minus 7. And so that's what we're evaluating it for. Now, you always want to simplify things. So this isn't done because we're actually going to do some of the rule, okay, and put this in simplest forms. So we're going to distribute the 4 to both things inside the parentheses. So that's going to give us -4x minus 28. minus 3 because the minus 3 is part of this f function, so we got to include it. And now we're just going to simplify it. So it's going to be negative 4x minus 31, and that's what f of g of x is. So let's try it in the other direction. Let's figure out what g of f of x is. Okay, so we're going to take the f function, this information, and put it into the x value of our g. Okay, so again, we want to look at the shell of g. Remember, x is just some placeholder, so we still have to have everything else that's in the g function has to be in, our composition here. Now this negative is part of the rule. The minus 7 is part of the rule, so they both have to show up. But now, right, they're going to show up like this. And so we're just looking to figure out what goes in here. Well, what goes in there is this f. So we're going to write it with the negative and the negative 7. And now we're just putting in the f function. Well, the f function is simply 4x minus 3. And then we're going to subtract 7. So again, whatever's going on out here, we better distribute. So when we evaluate g of f of x, it's going to be negative 4x, or when we simplify it rather, plus 3 minus 7. Now we're going to combine like terms. Negative 4x minus 4. And that's what g of f of x is. Okay, so I'm going to do another example, except I'm going to have a little bit more complicated functions, at least for the f function. Okay, because it doesn't really matter what the rule says to do. You still got to take your information, whatever you're looking for, and plug it in. Again, if you were going to have an input of a number like 2, well then you'd plug it into both of these places, right? Let's take a look at that. If it was f of 2, right, you would just take 2, square it, also plug it into this x value, right? You have to use every time you see an x. Okay, and then you would go about your order of operations and get 6. So when you evaluate this function f for 2, you would get the value of 6. So let's take a look at what f of g of x is. Now just because we have 2 places for the x value to go doesn't mean we treat it any differently. We have to put this g of x function into both places. And again, this is just a placeholder, but the rule says that whatever goes in there needs to be squared. Then you also have to multiply it by 2 and then add 6. So we're just going to put that g function in. To those blank spots. Right? Notice everything is staying the same, right? We're going to square it just like we were here and here. We're going to multiply it by negative 2 and then add 6 to it. Okay, and this is going to take up a little bit more room because of the simplification. But when we do it, again, we're going to have 3x plus 4. And that's what we're going to substitute in, because that's what our g function is. All right, now we're going to simplify, and you got to remember how to simplify correctly, right? Because now we have to square. That means FOIL in this case. And then distribute the negative 2 here, and then combine all of our like terms. So this is going to be 9x squared plus 12x plus 12x plus 16. Again, make sure you FOIL. Distribute, and please watch your negative signs. Okay, now we're just going to combine all like terms, and we have 9x squared. Got 24x here minus 6x, so positive 18x. And then 16 minus 8 is 8, plus 6 is 14. Okay, so f of g of x in this case gives us this quadratic. Okay, but the process is identical. The functions are, the rule of the functions are a little bit more work, but this is what you should get. So now let's take a look at going in the reverse direction. So we're going to find g of f of x. And again, right, everything in this rule has to happen to whatever we're plugging in. So we're still going to multiply it by 3, and then we're going to add 4. Okay, so what goes in here? Well, the f function does. So then it's going to be 3 times the f function plus 4. So that makes it 3 times x squared minus 2x plus 6 plus 4. Make sure you do your order of operations correctly. So we're going to distribute this 3 to everything and get 3x squared minus 6x plus 18 plus 4. We're going to combine our like terms. So g of f of x equals 3x squared minus 6x plus 22. Now this idea is used often in science or particularly probably chemistry and physics, where part of a formula that you're working with is the answer to another formula. So there is one other thing I'm going to show you where we would actually plug in a value. So for this example, I'm going to use some basic functions just to streamline it a little bit. And let's say we want to find a value of all of this. We have a specific number that we're going to plug in. And so the question could be written a couple different ways, right? It could be f of g of negative 2, let's say. Okay, and again, I would write it this way, f of g of negative 2. Okay, so there's a couple different ways to think about this, and both of them are correct. So when I do f of g of negative 2, I'm going to do it one way, and then when I do g of f of negative 2, I'll do it a different way. Okay? So the first way to do it is to simply find what f of g of x is first. Okay, so let's do that. Our f rule says negative 4 times whatever we're looking for, in this case g of x, plus 9. So that's going to be negative 4 times 2x plus 7 plus 9. So that gives us negative 8x minus 28 plus 9. So f of g of x is negative 8x minus 19. Now, we're not done because we wanted to evaluate all of this for negative 2. So now you can just substitute negative 2 in for your x values. So f of g of negative 2 is negative 8 times negative 2 minus 19. And again, make sure you do your order of operations correctly. So f of g of negative 2 is 16 minus 19 for negative 3. So that's one way that you can do it. And I'm going to show you g of f of negative 2 in a slightly different way. So g of f of negative 2 is what we're going to do this time. And since we actually have a numeric value, we're going to plug that in, because really what we want to know first is what the heck is f of negative 2. So let's just find that out. F of negative 2 is where we plug in negative 2 into this rule. Oops. Okay, so we're going to find it 8 plus 9, which is 17. So that's actually what f of negative 2 is. Okay, but the complete question is asking what g of f of negative 2 is. Well, since this inside is actually 17, what we're really doing is figuring out what g of 17 is. Okay, so then we're going to take 2, multiply it by 17, and add 7. Okay, because again, the rule of g says multiply whatever information you want by 2, and then add 7 to it. So when we do that, we get 34 plus 7, which makes g of 17 equal to 41. Okay, well, g of 17 is the same as g of f of negative 2. Okay, so either way is correct and will yield the same answer as long as you do it correctly. So it's kind of your choice.